In today's process industries, energy efficiency is an economic necessity. The PILLER industrial heat pump is the ideal process tool providing energy savings, especially to energy-intensive process industries with high steam demands such as the thermal separation processes, chemical, petrochemical, and pharmaceutical industries, along with industries involved in basic material production, paper, and food processing. Our heat pump system is the ideal solution for heat recovery in these process industries, providing several megawatts of thermal energy and steam at high temperatures. This innovative system is perfectly suited for retrofitting existing plants. The components of the heat pump can be placed individually, for example, on platforms above the existing process plants. The integration of our system and the resulting improved energy efficiency saves energy costs by more than 50% and leads to project payback periods of less than 2 years. By reducing fossil fuel use, CO2 emissions are reduced, and in contrast to conventional heat pumps that use chemical refrigerants, the PILLER industrial heat pump uses the existing process fluids, either the vapor from the process or water. The integration of the system thus contributes significantly to climate and resource protection. Let's take a look at the energy consumption in a conventional process with high demand for heating steam, which is generated by burning fossil fuels and some additional electrical energy. The retrofit with the PILLER system recovers waste heat from the process and supplies steam using a minimum of electrical power. The comparison of the existing system to the PILLER system shows the remarkable savings of our solution. Over 50% savings in energy costs and more than 60% reduction of CO2 emissions. The successful conversion to an industrial heat pump made by PILLER starts with the analysis of your individual process. In principle, all plants with a thermal separation process, such as distillation columns, strippers, evaporators, crystallizers, and some reactors, generating vapors, are suitable for an optimization with a PILLER industrial heat pump. In this simplified example, a mixture of substances is separated into its components, and component A is released as a gaseous overhead product, and component B as liquid bottom product. The evaporation process absorbs almost all the heat supplied by the heating steam, which is either directly injected into the process or transfers the heat via a heat exchanger. In the conventional process, a boiler produces the required steam by burning fossil fuels. The fuel consumption to supply the steam is one of the reasons for high energy costs and greenhouse gas emissions. Following this process, the overhead vapor is condensed. The reason for condensing overhead vapor is to maintain the pressure level and recover the overhead stream as liquid end or intermediate product, or to return it into the process as reflux. The excess heat is dissipated to a cooling water circuit, condensing the overhead vapor. In addition to high heat losses into the environment, the cooling system uses costly electricity for cooling water pumps and fans in cooling towers. PILLER offers the solution for more energy efficiency and cost reduction. The energy supply is optimized by linking the steam demand with available waste heat sources. Due to the temperature difference between low-temperature waste heat and high-temperature steam demand, a heat pump is required. In this example, the PILLER industrial heat pump recovers the waste heat from the separation process in an evaporator. Boiler feedwater or condensate from any process can be used here. The required steam is generated at a relatively low pressure and temperature level. Process waste heat is used as heat source for generating the steam. The thermal energy is transferred to the water condensing the overhead vapor. This form of heat transfer has major advantages. Compared to other fluids, water has a very high heat of vaporization and can be integrated into the existing infrastructure. The evaporator is specifically designed to meet the required heat demand and process conditions, defining the mass flow and temperature of the generated steam. The system's core is the compression with our perfectly engineered PILLER high-performance blowers. For high temperature differences, a multi-stage blower system lifts the waste heat from low temperature back to a usable temperature while preserving the heat of vaporization. The multi-stage arrangement of PILLER blowers opens the system to integrate additional waste heat sources. Excess steam, like flash vapor from other processes, can be combined with the freshly generated steam in a laminator. This flexibility of integrating other sources at any intermediate stage allows even more heat recovery. Feeding back the compressed vapor into your process or into a steam network will preserve energy and reduce greenhouse gas emissions. Paramount to this success is the PILLER impeller design with efficiencies up to 87%. The special design of the blowers according to the process requirements. And the controlled water injection for de-superheating and providing saturated steam. Heat recovery using a PILLER industrial heat pump with previous steam generation and subsequent compression is always the perfect solution if direct vapor compression is not possible, saving energy costs and reducing CO2 emissions. The PILLER industrial heat pump, always a winner.